So I'm kind of focused more on the physical hardware and the connectivity and the presentation of these kind of resources, so that the data science can then do their magic, right? So there's a couple of things I'm going to talk about here, but before I go into it in kind of some of the technical details, I want to talk about why it's important here, right? I mentioned that we've been working in the space for several years now. And there's some things we've learned from our customers here, right? The first thing is that AI model development, actually training and validating of models, takes some pretty specialized infrastructure. It can be done on CPUs. It can be done anywhere at any time. But the big challenge is the amount of time it takes to get it done, right? So there's a lot of customers who are starting their AI journeys on CPUs. And then realizing that it just simply takes too long. I think one of the early quotes that I loved from the NVIDIA guys was that the accelerators allow a data scientist to see his life's work done in his lifetime, right? Instead of these techniques have been around for 50 years in some cases. The guys who invented these techniques never saw it actually work because the compute was just literally not fast enough, right? So with the specialized infrastructure, that's getting really challenging for customers these days, when most customers are downsizing their data center footprints. They're outsourcing IT initiatives and support and stuff. So the notion that we have to bring in some new kind of big iron horsepower is really challenging for a lot of customers. That in itself, as Max mentioned, is actually driving shadow IT, right? The data scientists are fed up with waiting for the IT guys to give them something they can use. They swipe their credit card and go get some compute in the cloud, or they go buy a system from whatever vendor walked through the door and said, that, hey, we got this great thing, and it may be great for that guy on that day, but as the business matures and as the needs grow, those things almost never work out, right? There's a reason why people don't like shadow IT, and down to some of the compliance things, right? Data scientists may or may not really care of the legal ramifications of some of the things they do, while their IT departments and their corporate compliance officers are extremely interested in the things they're doing.
Where do you come up with that first number? Because in any business of any sort, there's all sorts of small projects or pilot projects that aren't ever really intended to go into production. They're intended as a once-off type thing. So coming up with this 53% number,
well, that number came from a Gartner survey down there in the bottom.
Yeah.
I didn't pull that number out of thin air.
Gartner pulled it out of thin air.
Gartner may have pulled it out of thin air. I won't dispute that fact, but I got it from somebody who claims to know what they're talking about.
Okay, it's a meaningless number as far as I can tell.
It is, and that number varies from customer to customer, right? We've definitely seen customers who are essentially clueless at what they're doing here, and they're fumbling around in the dark, and they got a data scientist, and he showed somebody something really cool, and they said, okay, let's do more of that, but they don't really know what they're doing, and they don't really know how to get it there. Then we've got customers who are way beyond that number, and they're already actively getting mature projects into production.
Okay.
Right?
Or they've embraced fail fast.
Or they've embraced fail fast. Right?
One of those two things.
I'll say getting that kind of infrastructure and those kind of capabilities in-house and usable by the users who need them is a part of that problem. I'll say, to that point, right? Like, it's really easy to build data sets that are a lot of the challenge we see with getting things into production in AI, to your point, is it's not about, like, can I get a server and put an application on it and run it? The challenge is the data, right? And the data is coming from everywhere. And I'm going to kind of go into a little bit more of this in the beginning, but it's easy enough for a data scientist or a data engineer to pull together a data set that he can experiment with, that he can show something interesting that appears to solve his problem. That's not that big of a challenge. What's challenging is reproducing that every single week, so that every week you get new updated data, the models get updated consistently, and so on. And that's where things start to break down, because that one guy who spent days and days and days building and massaging that data set can't spend the rest of his life doing that same thing, right? That was just to get it off the ground. So that's been one of the big challenges.
So I'm interested in your last number, actually 80-90%. There's a lot of at least IT departments that and data centers where they say they have, you know, virtualization first approach. They're going to virtualize everything, which I'm not sure I agree with as an approach. But how much of a problem do you think that is when you're talking about AI systems?
Well, so that is actually one of the things NVIDIA's got a solution, right? The challenge to address here is that at the end of the day, this specialized infrastructure is expensive, it's complex. Like I said, IT departments are losing skill sets. They have VMware estates. They know how to run VMware estates. They know how to use that platform, right? So the goal here is to actually get that into use for the AI development, right? I mentioned that, you know, you can do AI on CPUs, and there's a lot of customers who are doing it on VMs because that's what's easy enough to deploy, right?
Yeah, yeah.
The next step of that evolution is to give those people GPUs in their VMs. And so one of the things I'm going to talk about in a minute here is the NVIDIA AI Ready Enterprise program, which basically layers a whole bunch of this cool NVIDIA software on top of the VMware infrastructure, right? Using servers that have GPUs and so on, really allows you to kind of achieve all of the kind of functional benefits without maybe the big iron horsepower benefit, right? So maybe you don't have a 20 node cluster of DGX A100s or something, but you've got 50 or 100 servers with one GPU each in them, and every data scientist gets his own machine, and you know, those kind of benefits. So there's a lot of benefit to be had from enabling AI development in a VMware environment. And I can touch on that in a bit more here. Well, and that pretty much covers what I wanted to catch here. So to that point, right, the challenge here, like I mentioned, is not necessarily around just having a machine that does it, because the machine itself is only part of the process, right? There's a whole range of things that need to happen. There's a whole range of access requirements, right? Like what protocols users use for certain steps, what other things are there. There's kind of three key infrastructure solutions I want to touch on here. One of them is our Ontap AI. That's been kind of our flagship from the beginning. That's actually available in kind of three flavors now, basically as a do-it-yourself reference architecture. It's also available as a turnkey. I want to call it a single SKU solution, right? So you can order from a partner vendor, basically the servers, the storage, the networking, and some of the software bits to build a complete solution. We've also got the DGX Foundry from NVIDIA with NetApp that Adam's going to talk about here in a lot more detail. But that's basically this architecture as a subscription-based service, so you don't have to buy anything at all. You can just rent it and immediately go to work on it. Excuse me. You may have heard last week our big announcement for SuperPod, the NetApp E-Series storage system, was certified on the SuperPod platform. NVIDIA DGX SuperPod is the NVIDIA, you know, basically world-class blueprint for a world-class supercomputer. And then the last thing I mentioned there was the NVIDIA AI Enterprise. So I'll touch on a couple of details there. But this is the picture I was going for next here, right? This is kind of a better look at, you know, across a whole range of development options here. There's a lot going on in this space, right? It's not just as simple as collect some data, run a training job, whatever, right? That data has to come from somewhere. We usually kind of call that the edge. That may be a drone flying around or an autonomous car collecting data. The edge may be the data center where you're collecting data telemetry from a website, right? Click-through rates and things like that from a website. So anywhere that data is coming from, it's going to have to get somewhere else, most likely. Sometimes those things are happening in the same data center. Sometimes they're not. The drone is not doing the heavy lifting right there on the drone, right? But what's interesting is the drone may be doing inferencing, right? The whole point of these AI models is to put them in the environment to interact with the way they've been trained to do, right? So the inferencing usually happens out there at the edge. That's where users are interacting with an application, or the autonomous car is interacting with the environment, or what have you. And not only are you collecting the data that's coming in, that's just the data, but now you're also collecting data about what your model is doing How accurate is your model performing in the real world? How many anomalies are you seeing there? So it's kind of a compounding problem, but at the end of the day, it's referring to both kind of an ingest process and an analysis process that may or may not be happening in the same location as any of the other parts of this process. The data factory is where kind of the sausage making happens, right? That's where that raw data gets labeled and turned into actual data sets. Again, like I said, there's lots of different access requirements. Some of these are web-based applications where you don't even need anything but a web browser. Others are more direct NFS or kind of S3 type things, depending on whether they are using pre-built services or things that customers have cooked up themselves. But because that data factory is now kind of an aggregation point for all of that data, there's a lot of other things going on there, right? There's other kinds of analysis coming on. There may be other data streams coming in from a Kafka stream or existing databases, business CRM databases or things. And of course, Hadoop has been a huge part of a lot of analytics shops for a long time now, but a lot of those customers have kind of run into the limits of what Hadoop is capable of, and are looking more to things like Spark on Kubernetes. So Max was talking about Spot Ocean for Spark on Kubernetes, right? It almost makes more sense to spin up those analytics engines, as many as you need on demand, than to maintain a fleet of 5,000 servers in a Hadoop cluster and try and maintain that, right? So there's a lot of things going on there in that data factory. That may or may not be one data center. There may be multiple locations around the country or around the world where those kind of tasks are going on. And then the last step there is the training and validation of models. And we've been talking a little bit, about like HPC and stuff. This is where those things start to merge together, right? There are customers who are making these big investments in this kind of hardware to do not only AI development, but also more traditional HPC simulation type workloads. And all of that can still feed back into this whole kind of, I had a colleague who called it the virtuous cycle of data, right? You get some data and you build a model and you get a result out of that data. And that teaches you more about how to do what you're trying to do, which lets you collect more data, which helps you build a better model, which helps you collect more data, which helps you build a better model, and so on. So the circle goes on.
You were talking about your SuperPod with the E-Series.
Correct.
There's a question about whether your DataOps SDKs actually work with E-Series and SolidFire product lines, or are they Ontap only?
So the DataOps toolkit does work with the BGFS. So I'll go into this E-Series thing in a bit more, but at the end of the day, it's not really the storage system at that point, it's the file system, right? So the E-Series, we have a Kubernetes CSI driver for the SuperPod solution. And we can do some of the things with the DataOps toolkit that the platform supports. But like the E-Series, like BGFS doesn't support snapshots the way Ontap does, and doesn't support cloning the way Ontap does. So some of those features we can't directly implement. But in general, yes, you can apply a lot of the same concepts there.
Okay, and what about the SolidFire product line?
The SolidFire product line, I don't believe is supported at all, right, Mike? Correct. Okay. Okay.
Thanks.
I don't think we're actually selling the SolidFire directly anymore either, though.
Isn't it based on your HCI solution? Isn't that
HCI is discontinued, but I'm quite certain that SolidFire is still selling to several very large customers.
A couple specific customers. That wouldn't surprise me. I believe it is not generally available anymore, though.
Okay.
At right about the same time the HCI was discontinued, I think is when we stopped doing the SolidFire generally available as well. Okay, so the first one, the Ontap AI. This was the thing I started with.
I'm curious with the NetApp Fabric from before. Are you going to talk about like all the products that make up the fabric? Because there's a lot of elements there from the same kind of semantic field, as in inferencing with custom Kafka, but what exactly is the data fabric?
So the data fabric is a concept that NetApp came up with a couple of years ago. basically referring to the interconnectivity of all of these different storage products we have, right? So the Ontap product that I was getting ready to start on has a few replication features built into it natively, and a lot of the things we've been talking about would rely on SnapMirror to move data between, you know, heterogeneous or homogeneous Ontap systems. For customers that have heterogeneous systems, or even like the E-series, right? If we want to move data between that E-series BGFS and an Ontap, we have a couple of other software components, like CloudSync is one of the products we have that can basically move data from any source location to any other source location, and can be automated. We have another product called XCP, which is currently mainly used for NFS migrations and Hadoop migrations. But we have a roadmap of support for a broader range of protocols. The big one is going to be S3 coming with XCP here shortly, in order to be able to tie together any of those environments. So we have a couple of other tools for actually moving data between the storage components. Does that make sense?
Yeah, it does make sense. So is the data fabric more of a umbrella marketing term?
It is, yeah, because there's basically a suite of products that effectively kind of make up the notion, and the idea is that, you know, based on having different, you know, every customer is going to have different requirements and pipelines, right? The data is going to be coming from different locations, so there may be different requirements on what data movement is required and so on. And the data fabric just kind of provides a framework for us to help move the data around between any places as needed. Ontap AI is just the reference architecture, right? This is basically all of the major storage vendors have an architecture that looks pretty much identical to this. I'll say from the actual workload testing that's been done, they all perform exactly the same too, because for the actual machine learning workloads, the storage is generally not the bottleneck. There may be small phases of the process where more bandwidth is required or not, but they have a very minimal impact on the overall performance of a training job. But the idea here is really to provide the customers with a pre-validated solution. We've already built it in a lab. We've done all the engineering work to identify any issues. We've tested it with both synthetic workloads and with like MLPerf benchmark workloads. And then provided prescriptive guidance for customers on sizing and deployment. You know, we do have a document with literally step-by-step command line instructions on how to deploy and configure this whole solution, but nobody wants to do that anymore. So we've also got Ansible automation to deploy the whole thing in about 20 minutes. I've run this whole setup in about 20 minutes. I use this automation in my lab because I tear these things down and rebuild them on a regular basis. And I can basically have this whole stack up and running in about 30 minutes when I reload operating systems and everything.
Is this the SuperPod, or is this your own version with DGXs?
So this is not a SuperPod. This is what NVIDIA calls a scale-out cluster, as opposed to a SuperPod cluster. This is, I'm going to touch a little bit on why you might want to choose one over the other in a minute. But no, this is not the SuperPod. I'll show you the SuperPod here in a second. The next iteration of that Ontap AI is, like I said, a single SKU model, right? So customers can work with their partners. They don't even need to be a DGX reseller, I believe. As long as they're a NetApp reseller, any partner who sells NetApp can sell this Ontap AI integrated solution. And that's because, again, all the engineering work has been done. This is being done by the distributor Arrow. They're literally assembling it in their integration facility, installing all the software, testing everything out. Then they take it apart and ship it to the customer, stand it up on the customer site, run the validation test again to make sure it's performing as expected, and then hand it over to the customer. There's really two really nice features about this. One is that it is pre-built, right? Like you just say, I want 3 DGXs and X capacity of storage, and we can put a config out there that basically comes as a single line item. The other really nice thing about that is a single point of contact support for the entire stack. It's basically one phone call to NVIDIA. We've made arrangements on the back end for NetApp to support this with NVIDIA on the back end, but customers don't have to decide who to call. They call NVIDIA, and if NVIDIA determines it's a NetApp problem, they get us on the phone and we resolve it together. And that's a really nice feature. That's been one of the big challenges a lot of customers have, is dealing with kind of the support implications. I'm really briefly going to touch on this because I'm going to let Adam have all the fun with DGX Foundry. But as I said, this is a subscription-based service for the same thing, right? So rather than having to even think about making a purchase and spending capital expense, customers can rent this architecture for a monthly subscription basis and take advantage of not only the physical infrastructure, but also a lot of the really cool software development that NVIDIA has done for their internal development teams. I really quick have a customer case study on Foundry. This is one of the customers that did a proof of concept with us. They used a 20-node DGX cluster. Now, this was only tied to a single A800 storage system, so we got a really good ratio there, and they did not see any performance issues with the workloads that they were running on. Back to my point about these workloads are generally not storage constrained. So depending on the actual workload and the requirements, there's no hard, fast number that you have to have X throughput of storage for any given server combination. These guys ran over 700 training jobs. I think they had the system for 2 weeks. So in about 2 weeks, they ran 700 independent jobs and logged 15,000 hours worth of GPU time, which is really good, right? The whole point of all this is to maximize the utilization of those resources. And the customer basically, they were onboarded. They get kind of a quick overview of how to use the system, and within minutes they're actually up and running and starting to train models and stuff. So this is just a really good example. This is now going GA, so this is becoming generally available for all customers. But this was one of our initial proof of concepts here. So SuperPod. SuperPod is kind of a totally different animal. The SuperPod architecture is basically NVIDIA, like I said, it's NVIDIA's blueprint for world-class supercomputer, right? If they were going to design the very best systems, and of course they have, and they've built them internally, SuperPod is the architecture that they use to do that with. And then they have kind of codified that and standardized it and made it available to customers. So there's only a couple of storage vendors that are qualified to do this. NetApp is now one of 3. I think there's a 4th on the way. But the idea is really to have built and tested this solution that is capable of scaling up to the largest. So a full-scale SuperPod would be 140 DGX A100 nodes right now. And the storage system that goes with this has to be built in a way that it can scale along with the compute up to that node. So we've developed a building block system, and I'll show you that in a second. That allows the storage to scale up with whatever the compute configuration is. SuperPod is deployed as a single item by NVIDIA as well. So it comes with the services to deploy it and then validate it to make sure it's actually delivering the performance it's needed. And then, of course, the whole thing is backed by both NetApp and NVIDIA again. The storage system here, as I mentioned, is the EF600. This is a very high performance but kind of lower feature set storage system that was really intended for HPC type workloads. That's where we've been selling this thing for many years. The SuperPod configuration then is basically we've created these building blocks, and a building block is essentially this picture is not actually accurate. It should be 3 EF600s combined with a pair of x86 servers. Each of those building blocks is then good for about 60 or 70 gigabytes of read throughput per second. And then multiple building blocks can be scaled up to whatever size is needed for the compute complex that's being used.
You mentioned 140 A100s. Is it possible that it's 160?
Well, the current SuperPod definition is 140, right? But I know there have been some plans on maybe changing the scalable unit size. Is that?
But it's 20 times 8.
There's 7 SUs is the max right now for a SuperPod.
So the SuperPod's based on a scalable unit, yeah, which is 20 DGX systems. So all of the SuperPods are basically in increments of 20. You can start out with 20 systems and then scale that up to 7 scalable units. Like I said, this is a different architecture than the Ontap AI. The Ontap AI was in numbers of 8. Because with our testing, that's where a single HA pair kind of maxed out, was with 8 servers on the machine learning workload. For the SuperPod, it's a true parallel file system that can be scaled out across as many nodes or storage devices as necessary. So it is intended to really grow to a much larger scale. The building blocks here, like I said, we've got these building blocks. Each building block is itself a high availability unit. So the two servers are basically redundant for each other. The two servers are running the BGFS storage services. Let me back up a little bit and say, I don't know if anybody is familiar with BGFS, but there's a company in Germany called ThinkPark that is the owner and maintainer of BGFS. NetApp has developed a really strong relationship with ThinkPark to the point where we now sell BGFS off of our price book, and we support it off of our support services. So we have level 1 and level 2 support for BGFS. And then, of course, we have direct escalation to ThinkPark engineering if we find issues that we can't resolve ourselves. So that BGFS software is running on the x86 servers. They are running as a high availability pair for each other. They can both access all of the storage behind them. And then the BGFS allows for distribution of those services. So if even more availability or even more performance is required, you could actually mirror the same data across multiple building blocks if you really wanted to scale up that performance or reliability.
But this would not be integrated with the earlier in terms of the data.
So not to the level that Mike showed, right? So, well, for one thing, SuperPod comes with its own management stack. And so that integration has not been done there as well. That being said, it's possible pending provided the feature set is there, right? We're still there's some feature gaps between the BGFS kind of because of the nature of the animal there. I'll say real quick, this we've got Ansible automation for this as well, right? So the storage components here go in very, very quickly. They've been automated and validated, so from an orchestration perspective, to your point, right? A lot of customers are running Slurm on this architecture as more of a traditional HPC batch job scheduler, but a lot of customers are also looking at running Kubernetes for more modern workloads. So like I said, there is a CSI driver and there is some compatibility with the data ops toolkit. It's just not a complete integration because the platform doesn't support all those features. Okay, so the other thing I'll point out is that we did just go through all this certification for SuperPod, and that was an extremely rigorous testing process. But this configuration can be used anywhere. We have lots of customers who don't want a full-scale SuperPod, but they still like the idea of a parallel file system and things like that. And of course, we have a number of customers who are buying basically this exact configuration for non-SuperPod type configurations. Okay, so which one's right for you, right? I've talked about two pretty high performance platforms, and that raises some questions about which one is right. I'll say for 99% of the customers out there, it's personal preference. They both perform well enough that for 95+% of the workloads you might run on it, you would never notice a difference in any kind of performance. A lot of the enterprise customers we're talking to are not friends of InfiniBand architectures. They don't really understand InfiniBand. That's not a part of enterprise data centers really. So they really like the notion of a solution that runs on the protocols that they're already familiar with and using, like NFS. On the other hand, we've got customers, and especially in the AI space, who came from HPC backgrounds, and they'll accept nothing less. So we have the SuperPod and the InfiniBand solution to kind of satisfy that personal preference. I will say there are some workloads, things like the true HPC simulation, like the oil and gas and genomic simulations we see a lot of people are doing. That definitely lends itself more to the SuperPod type configuration. And there are a couple of AI workloads like the large scale natural language processing and natural language understanding, where the way that giant cluster accesses data lends itself more to the parallel file system because it's capable of distributing that load a little better. So there's a couple of options here. NVIDIA and the AI ready platform, right? So you're probably familiar with NVIDIA's NGC suite is the whole software stack of all the kind of pre-built containers, models, software toolkits and everything. The whole idea of the AI ready enterprise platform is, like I said, customers have existing VMware estates. They know how to operate them. They know how to optimize them. All we really need to do is get some GPUs in there and they can start taking advantage of that platform for AI development, NVIDIA basically makes it super easy to pile all of that other software that used to only run on top of a DGX on top of any virtual machine that has got a GPU in it, so that it can enable users at a much smaller scale. And of course, this really lends itself to the notion that there's a lot of customers who don't want to make that big investment, but want to see if they can reap some benefit from AI. And the AI Ready Enterprise platform, that's a mouthful. I can't say it enough. Really provides a nice roadmap to get there, right? It really enables all of those software capabilities without having the massive investment in the infrastructure. Max talked a little bit about cloud AI. I'm really only going to point this out. This is kind of an example of a validation. We've got several workflow validations where we tested this. We offer basically the same cloud services in all of the major hyperscalers, so customers can use whatever compute they would like to use, but still take advantage of a lot of the NetApp features. And to be clear, on ANF and on Amazon FSx for NetApp ONTAP, that data science toolkit integration all does work, right? It's all exactly the same ONTAP under the cover, so all of those same calls work together. One last thing, I don't know if anybody is familiar with GPU direct storage. The one thing I want to point out, we're the only vendor who supports it on two platforms. Both our ONTAP systems support it and that E-Series system with BGFS. We had to do a little development work with ThinkPark to actually get that code into the BGFS, but that has been released and is GA. And then on ONTAP, we can support GDS using NFS over RDMA starting in ONTAP 9.10. And then we've got some more features and enhancements that are coming on the